Hello everyone, Dr. Mo, and today we're gonna talk about data preparation with Python. The reason that we wanna prepare the data is because usually it has missing or anomalous numbers or the format is not good. So there are so many things that we need to take care of before using this data in machine learning projects. All right, so we're gonna start with importing data. We're gonna look at the dataset in pandas data frame format and its columns and indexes. We'll visualize basic statistics like what is the format or missing values and so on. In the next step, we're gonna talk about filtration, filtering rows and columns based on different conditions, and this is going to help us to manipulate the data because sometimes we want to replace or drop missing values or change the formats. So let's get to the code and we'll talk about each section in details. Okay, let's import the data, and we can import the data from files. These could be text files or CSV files or other formats, and they can be imported from databases. These are usually companies have different databases, Oracle or MySQL or Snowflake or different other databases, and it could be also scraped from the web. So these are like comments or any other information that you can find in the internet. You can go and load them to your pandas data frame or any other format in the Python. So in this course we're gonna talk about mainly tabular formats, usually CSV files, and there are other good references that I'm bringing here. You can go over how to connect to a database and read it from there, or how you can scrape your data from internet. Okay, and let's also import two important libraries. These are gonna be used very often, and pandas, we're gonna work with usually different manipulation methods inside the pandas, and NumPy is going to be mainly used in the usually last stage to convert things to numerical arrays, and these are going to be used in the scikit-learn for your machine learning purposes. Okay, this is the link that we're gonna work with. So I'm gonna usually load it from GitHub link, but you can load it locally. It can be CSV file or whatever. So I know already the data format is in CSV format, so I'm using read CSV of pandas. And if I load this, and look at head of the data frame, we see different rows and columns, but the first thing that you're gonna see is the first row is considered to be as header, which is not right. We can fix it with two steps. One, we are gonna specify the name of columns, and then we're gonna say that there is no header for this data frame. So we can specify those column names here. These are each strings, which we know already each column, what is the name of that column. We are putting in different strings in a list, Python list. And then in the read CSV side, we're gonna say header is equal to none. So this is gonna take care of that first column. In the names, you can specify those head names, which is list. And now you're gonna have write column names in your data frame. Alright, after we load the data frame with write headers, we're gonna look at the basic statistics. For example, we're gonna see what is the shape of the data frame, which shows roughly 32,000 rows with 15 columns. And Pandas also has a very good method called info, which quickly gives you the type of the each column. For example, first column is integer, second column, which was for class, is object. Object is usually string or another object, but we know here it's string, and so on. There are other data types like time, date time, and we're gonna cover them in later courses. But for now, we kind of know what is the data type for this data frame. And another column is non-null count, which shows you how many non-null values each column has. All right, after you get the info, you can use another method called df.adult describe. Describe is a useful method which goes to numerical columns and gives you basic statistics like how many numbers you have, mean of that column, standard deviation, minimum, 25% quartile, and so on. Okay, now it comes the important part, filtering columns and rows. To do that, we're gonna use another data set, which is called police.csv, and we're gonna set the index column as date. This is one of the columns that you can go and see. That's one of the columns in this CSV file, but for now let's assume that we know that and we put it there. So if we run this and look at the columns and the index, we're gonna see that we have set the index here. So basically, if we wanna look at columns in just list format, we can say df.columns, which is gonna give you a list of all column names, which are strings. Each one is a string, and we can go and look at index also. So df.index is gonna show you all these indexes that are used in this data frame. All right, but what if we want to select just some of rows and columns, say these rows and these columns? Then Pandas data frame has a very good method called loc, where you can specify your columns, say these first you can specify the rows. Rows are these ones. Say I'm gonna copy them and paste them here. I'm gonna put comma, and I'm gonna put these in as a string. And the reason is, if you look at the df.index, it says the data type is object. Object is usually either another Python object or string. But if you look at each number, each date, they have been saved as a string. So that's why I have to put them as strings. And so these are rows. For the columns, I'm gonna use another square bracket and the name of columns that we want to select. Again, these are gonna be they're gonna be another strings. So if we execute them, you're gonna see that we have a smaller data frame with the selected rows, 2 rows and 2 columns. But what if we want to select the rows and columns based on numerical numbers, say first or third or fifth column and 6th or 10th rows? Then say, for example, if we want to select first and third rows, we can use another method of pandas called iLock. So iLock or lock is gonna act similarly. We're gonna give the rows rows indexes in the first square bracket, which is first, third, number 3 and 8. And for the columns, we're gonna use another square bracket with the indexes, which I believe we were interested in the second and fifth one. Now if I run this, I'm gonna get the data frame, new sliced data frame, which has 3 rows and 2 columns. But another important way of slicing data frames, which we are gonna use a lot, is filtering rows based on conditions in columns. So the general format is gonna be, say we're gonna have different conditions. We're gonna put them inside the square bracket of the data frame, the original data frame. So we have the original data frame. Any condition, we're gonna put them inside that square bracket just in front of the data frame. So for example, if we want to look at the drivers in this data frame, this data frame is about drivers and police who caught the violent drivers and gave them tickets. And if we are interested in the drivers who age less than 35 years old, we can create that like this. The name of data frame was df, and the column is, so the condition is gonna be df age, or the driver age should be less than 35. So this is the condition, which is inside the square bracket just in front of the data frame. If I execute this, I'm gonna get all the drivers who age less than 35 years old. So we can put many conditions here. Say I have this condition and also I want, so I'm saying and another condition, say just females. So that female is in the driver gender column. So I'm gonna say df gender, I want that to be equal to female, right? So first condition and second condition, and this can go on and on. So if I execute this, you see that all female drivers with less than 35 years old, we have filtered them. Sometimes we want to drop some of the columns or rows, so we can use drop method, and we can say, for example, if we want to drop these two columns, let's copy them. We can say df drop, and inside square bracket we can list any columns that we are interested in dropping, and also we need to specify the axis, which is equal to 1. Axis 1 is column 1 or column, and 0 is index or row. So if we do this and execute it, you're gonna see that there are no columns named driver gender or search conduct. But the thing is, if we after dropping this, if we again look at df, say if I wanna look at the df head again, I'm gonna see that driver gender is still there. So what happened is it just dropped it, but it didn't drop it in place. We call it in place. So the thing is, if we say in place, by default it is false. So what it does the drop, but in fact it's not dropping it for always or permanently. If you wanna drop it permanently, you need to specify this as true, which is not a good way in many cases to do that. Even if you want to drop it for permanently, the better way is to replace or in fact put it into another new data frame, name it whatever you like, and then use that data frame. This is better practice. So now df new is gonna, if you drop it, you're gonna see that there's no driver gender or search conduct, but still df does have those columns. And similarly, for dropping rows, you can use df.drop. In the square bracket, you're gonna specify these two rows that you want to drop. They are string, and we need to just separate them by comma. And this time we need to say axis is equal to 0. And if we do that, you're gonna see that none of these two indexes are in the data frame anymore. All right. Another important method that I would like to talk about is when you want to say look at one column and it is a categorical column, and you want to see what is the distribution of those categories in that column. Say you want to see how many different races you have in this driver race. You can select that column first. So we can select race, driver race, and then use value counts with the parentheses. This is gonna give you very nice number on each race that you had in that column. It can be gender. What was the name of the column? Driver gender. So it shows more male than females. And now we are ready to move on to another topic. Say we wanna look at the distribution, but among different categories. So we wanna say among males, what is the percentages in different driver race. So we have like two-step question. We wanna first group by gender, and then we wanna look at the distribution of races in those categories, in those groups. So we can use group by method. So group by method is gonna be very useful. Say we wanna group by the whole data frame, group by driver gender. We can say df.groupBy, and we wanna group by it by the string called driver gender. This is the column name that we wanna group by. If we just run this, we're gonna see the output is just Python object. Now we need to specify the column that we wanna do further analysis. Say we wanna look at driver race, and still it is Python object because we haven't done any analysis. Now we can use a few available analysis. Say we wanna look at the sum of these numbers or average of these numbers inside these groups, or do some value counts. So for example, let's look at the distribution of races inside these two groups. So we can use value counts. So what it does, it first groups by driver gender. If you see, there are two categories here, and inside each it looks at the driver's race. So this is gonna be again very useful because you wanna compare in many cases two different groups or three different groups depending on what is your first column that you are looking at. So it's gonna group by the first column that you specify, and then it's gonna do the analysis, which this one was just value counts on the second column. Okay, now it's the good time to look at data manipulation, and as first step we're gonna cover format change because that's gonna come up too frequently. Usually you have data type that you want to convert to other data types. Pandas has a nice web page to document these data types. For example, the first one is time zone aware date time, which is aware of which time zone you want to work with. And the second one is categorical, and the third one period, which is a time span. We're gonna see some of these in the coming sections. So let's get to it. The data frame that last time we used was police data frame, but let's look at the head again. Yeah, we have it here. Now, if we look at the info for this data frame, we're gonna see that there are float, object, and Boolean data types. And now let's say we want to convert um, driver age, which is float, to string. Okay, so we want to convert this to string. We can specify that column that we want to convert, the driver age, and we're gonna specify as type. In the quotation we're gonna say str or string. If we execute this, you're gonna see that even though you cannot see specifically here, but the data type, which is in the output, it says object, which we kind of know. It's again either these are Python objects or strings, which we already know that it is a string. Or another way is gonna be just look at the first one. First one, the index is 0. If you look at this, you're gonna see that it is clearly a string because it is inside the quotation. Okay, let's remove that. Okay, now it's time to deal with time in pandas. Let's look at the index of the data frame that we have. If you look at it, it's the data type is object, so it's already shown also here that it is inside single quotation, so we know it's a string. There is a good method of pandas which we're gonna use a lot, especially in time series data. It is called datetime. Datetime format is very useful in pandas because you can resample your data frame, you can get your dates, hours, I don't know, months, or you can have very good access to different calendars and time zones. We're gonna see them more often, but for now, just let's look at how we can convert to datetime, because these are right now strings. So if we want to convert them to datetime, the name is also very simple to remember. You want to use pandas to datetime method, and you want to put the column you want to convert. So right now we want to convert the index, so we will put df.index, and if we execute this, it's gonna take a bit of time because this is usually if you have lots of rows, it can be heavy to calculate. So right now you see that d type is datetime, but we need to replace the index with the new index. So we can say df.index is equal to this newly converted one, and we can also take a look at it. Alright, so that's the date time. And now with this newly created or converted index, we can look at different things. Say you can look at months or month, which is a number between 1 and 12, or year. So it is smart enough to distinguish the year numbers, numbers related to days, and even hours. So day is gonna be different numbers between 1 and 31. Okay, now we can use this to answer many questions. So, for example, how many violences have been recorded each year? So to do that, we can look at index, year, and do value counts. This is the method that we already talked about. So we are just looking at year, and then we are doing the value counts. So if you look at it, 2012, they had almost 10 or 11k violences, and 2005 had the least number of violences. All right, now let's talk about filling missing values or filling NAs. There are three usually basic methods to do that. Either you want to replace the missing values with mean, which is used for continuous values, and it is commonly used in statistics. Mean is known for everybody. And median is also used for continuous values, but it is better in skewed and polluted data. So if your data set is, say, rightly skewed or left skewed, and if it has like large anomalous numbers, then it's going to be much better to use median instead of mean. And for categorical values, we can use mode. All right, let's look at an example. We want to look at the info of the data frame, and say we want to replace missing values in driver gender. So driver gender is object, and we know it's male or female, and its categorical column. So we can replace the missing values with mode. But for doing that, let's look at the mode. You see it is male in this column, but in fact we want to look at the value itself, right? So we want to look at this m as a string. We cannot use just this portion. We need to specify, we need the first item, or index 0. So let's name this as driver gender mode. Now we can use this parameter to replace, to fill NAs in this column. We had this column, and we want to use fill NA, and we want to fill NA with this DG mode that we just calculated. And if we do that, probably, yeah, you're gonna see here that the length is this, but actually it doesn't show that it is NA or not. It does have NA or not. So let's replace this column, the old column, with this new calculation that we did. If we do that, and then look at the info, this time you see that driver gender has 91,000, and it already replaced the missing values. Okay, so we are close to the end of this video. But before closing it, I want to say another important thing that we should be aware of is outliers or anomalies in any data set that you have. You need to remove it, and that's officially part of data manipulation. But because there are so many methods, I decided to put the link below. So we're gonna have different methods. If you are interested in any of those, please go and check that page. And yeah, that's it. If you have any questions or concerns, please comment below the video and I'll get back to you soon.